Okay, good afternoon or good morning as appropriate. Welcome to the fifth session of the fall 2016 Sunoikisis Digital Classics Digital History and Archaeology program. This week is the second of three sessions on geographical technologies, and we're very fortunate to have Dr. Tom Elliott from the Institute for the Study of the Ancient World at NYU talking to us this week about various cartographic approaches and tools and some of the issues behind that. And I think we'll learn quite a lot from this. So I'll hand over to you, Tom.
Right. Thanks, Gabby. And thanks to the whole Sunoikisis community for having me aboard. I hope that we can have a productive session today. The one caveat I'd like to levy before we get started is that there's really no way we can, in a single session, delve into even this one subset of geography completely, namely, how do you make a map of ancient stuff? And so we'll scratch the surface first with a demonstration using a couple of tools, and then do a little bit of unpacking where we look at some of the concepts, some of the concerns in the digital space, and some of the other tools that are available. But very much, I think this session needs to be looked at both as an introduction in its own right, and one that merely opens the door or hints in the direction of a lot of things that someone who wants to get serious about doing mapping and geospatial work will have to look at. But that also it is embedded, as you say, in this three-part series that's part of the course. And so there are some things we'll merely gloss or ignore entirely today that will come up in the subsequent session on geographic information systems. That said, none of this is a substitute for a formal course in digital cartography or in spatial analysis, or for that matter, an entire degree in same. So having tried to manage expectations like that, I'd like to go ahead and share my screen, and we'll do some slides and some demonstration stuff. Right. So we can get past the title page without too much concern. I really want to divide the hour that I'm going to be talking into four parts. We'll start with the rubber meeting the road, an actual demonstration. And what I want to do is pick up from Pleiades, which Valeria did such a fine job explaining to us a couple weeks ago, and make our way into one of the generally available online mapping tools that are currently at our disposal. And we'll do that by way of namely Carto, and we'll do that by way of another tool called Antiquity Ala Carte. And I'll explain each of those, and we'll walk through them. Having done that, then I want to talk a bit about, in very general terms, about measuring and modeling space. And so that's taking a look at spatial data, the structured information that we need to be able to do the kind of mapping we'll have just done, and talk about some of the problems there, because our tools and resources are getting to the point where, for some tasks, it can be a very simple and intuitive thing to produce a map. And this is a new experience for a lot of us who've been at this for a while. But you can just point and click your way to happy mapping and print it out, or slap it on your webpage, whatever. But in fact, there's a lot going on under the surface. And a lot of what's going on under the surface has to do with the data, approximations of data, matters of error, and so on, which I'd like to talk a bit about. And if you're going to talk about data in the digital space, we don't want to be too abstract. We want to talk about actually how we store and share that data. And so I'd like to look at files and formats. This is an area where, that is to say, spatial is an area where this has gotten increasingly confusing over the years, but in the past couple of years has actually got a lot clearer for the simple cases. We'll talk about what that means. And then with whatever time we have left, we'll throw open the doors to a broader discussion of making maps and some of the cartographic concerns, procedural concerns, design concerns that you at least need to be aware of, and that might indeed drive you for many cases to finding someone who's done this before to work with, or at least to give you advice. So with that roadmap in mind, let's move on to the mapping demonstration. As I highlighted in the overview, I want to start with Pleiades, the community-built gazetteer that Valeria introduced to us a week ago, and just remind ourselves of what's there and the information that's available. Then we're going to move on to a piece of software, again, a web-based thing called Antiquity Ala Carte. This is a tool that was developed by the Ancient World Mapping Center at the University of North Carolina in Chapel Hill. The principal work was done by Dr. Ryan Horn, who is still engaged both with the Mapping Center there and also with Pleiades. And there are a lot of things you can do with Antiquity a la carte, but the main thing we're going to do is have a quick view of its feature set and then use it to get Pleiades data from Pleiades into a format that we can carry away and do something else with. And that something else will occur in another web-based piece of software called Carto, which is a commercial affair, but it calls itself open. And does have a relatively open API and things like that. And we'll use a free Carto account to demonstrate how quickly we can get to a simple map. And again, we'll poke at some of its features. So with that in mind, we'll come out of the slides and into the real world. Well, real webby world, and go remind ourselves about Pleiades. Here's a view of Pleiades, and I'm going to scale it up a little bit because I suspect it's getting squished on a lot of monitors. Does that look generally legible to everyone on the call? Or do we need to pop it up a bit more?
That's probably okay. I mean, if people need to be able to read the text, it might be, that's probably okay. Yeah. Okay. Even on the YouTube, I think that's okay.
So I'm going to just demonstrate for us again what all is in Pleiades. I've just done a search for Apollonia, which turns out to be a pretty common name in the ancient world. We can scroll our way through the big long list of matches we've got in Pleiades, or if we like a particular one, of course, we can go visit it and be reminded of all the sorts of information that Pleiades makes available to users. I better make sure I'm not logged in. No. And so on. So this is Pleiades. It's a big pile of information about places, and those places have locations on the Earth's surface, wherever that's possible. They have names as recorded in sources or as used today, and other indicia like what type of a feature it is. All of this data can be had by anyone from the downloads page, and we can find it in various formats, some of which we'll discuss in a bit. But what it doesn't really do is make it easy for us to extract an arbitrary group of materials and then download just that data. Fortunately for us, we have Antiquity a la carte, which does do that. So Antiquity a la carte is updated regularly from the Pleiades data set and also incorporates information that the Ancient World Mapping Center adds that you can use to make maps and also to query the Pleiades data and make maps with subsets that you define. So we're watching it very slowly load the background tiles and information to give us a view of the landscape. And one of the things I tell people who start using Antiquity a la carte to do is that in the first instance, if you're just trying to get organized, get some information in, turn off that background information. And I am now getting an opportunity to demonstrate to you why I should have switched to Firefox, which is that Antiquity a la carte, there's some JavaScript stuff in it that doesn't work well in Chrome, so I'm going to switch to Firefox and go through that process again. How about So I was just about to demonstrate the process of turning off the background layers. This has the effect of not loading a very large number of images that are used to create this shaded relief map and then the color elevation coding that's put over it. And so we can go over here to the map layers tool. And I can't really size this up, I don't think, but we can go over here and turn off hillshade data and elevation data and inland water and find ourselves with a little sketch map that will relocate and zoom and pan much more quickly than one that has to load all of that stuff from the tiles. So the next thing we want to do is to get some locations for the places we're interested in. And in this case, it's going to be Apollonias from Pleiades. Since we started with that, we'll do that. And that's done with the search for features function in Antiquity Ala Carte. You click the button and you get a big form. And you can search for various kinds of things. I'm going to start just by searching for Apollonia as a name in any language, and I'm going to click the search button, and I get a list of 33 items, and they're all shown in tabular form here. One of the things we can notice about this tabular form is that each column corresponds to one of the attribute components in the Pleiades dataset. It's sparse. It's not everything you'll find in Pleiades, but it's every place, and you get some of the stuff, principally the names, the type of feature, and the time period codes that Pleiades use, and the Pleiades ID. This is the portion of the Uniform Resource Identifier that uniquely identifies this place in the context of Pleiades. I can add all these results to my map. And it will automatically label them for me. And then I can say, wow, I've got some stuff in here that I don't want. Maybe I just wanted settlements named Apollonia, so I can narrow my search. And restructure the map, which is now, there we go. So here are some Apollonias on a map. You may have other kinds of criteria that you're imagining you would search for, but these are the basics. I want to take a couple of minutes to talk about what else you can do in Antiquity Ala Carte. We've already looked briefly at the map layers section. We'll talk about layers in the context of digital tools for mapping in a bit, but this is a metaphor you're going to see come up again and again. Is basically the hierarchical structuring of information, calling them layers that compose or build up the map. And we'll talk about why that's a thing a bit later on. But remember, layers means the different thematic components you're going to put into your map. And there's an important graphic element to it, which is to say that layers stack. As I move down this list, I'm moving deeper into the map, deeper into the surface of the screen, and so a layer below another layer will have its features occluded by anything in the higher layer. You can do some other things here. One is to interrogate an individual place. So I've clicked on this Apollonia, I get a little pop-up that would allow me to edit the information right here. I'm not editing Pleiades, I am editing my map. I'm editing the copy of this information I've loaded into my map. So I could give it a custom name. We could call it Fred. And I could later on have access to that name Fred if I wanted to. I could also correct a value I didn't like or edit a value with the idea that this map is becoming mine. I'm moving from a general data source to the specific task of what I'm trying to do. There is a menu choice for labels. So I can now switch from the default, which is to use the Pleiades titles, to the custom labeling format. And for some reason, Fred has not shown up, but we'll go back to English names and demonstrate that we can do this with some of them. Here I've chosen Greek, and it so happens that only a couple of our places have a Greek name already specified in the data set, and so we'll find that for the purposes of our demonstration, moving back to Pleiades names is the most straightforward thing. I'll also note that the Antiquity Ala Carte tool gives you the ability to go without labels entirely, or to label by sequential numbers that are assigned based on the order in that grid view that we saw. This capability, as I understand it, was designed into Antiquity Ala Carte so that you could produce map quizzes for classes and students, and where the students would have to match the numbers up with a list of places that they're presumably pulling out of their head or that's in a matching list. Apart from labeling, we also have some map tools that can allow us to measure distances or draw things. And then the other thing I really want to point out to you is this interactive map gazetteer. This is again, a tabular list of the material that's on your map. And I'm having a little bit of misbehavior from the drag and drop JavaScript library, I think because of interactions with the screen share tool. But at any rate, that interactive map gazetteer allows you to delete a feature or even delete all features from your map, which I've just done. Going to go back and add our Apollonias again for the purposes of our final demonstration step in Antiquity Ala Carte. And that is the file menu. And on the file menu, there are mechanisms for exporting a map URL. This allows you to give somebody a link to your map as created in Antiquity Ala Carte, and they can pop right into it from an external source later on. There's also an export function, and that's what we're going to look at. You're given three options: to export as CSV, to export as JSON, or export as KML. I'm going to choose JSON, and we'll talk a bit more about these formats in a minute. But we'll export our map as JSON, and it's going to ask me what I want to do. I want to save this file. I'm just going to put it in my downloads folder, and then I'm going to go ahead and naively open it. What's going to happen on my machine is that the Oxygen XML editor is going to start up, and because I have it associated with the JSON file type. And JSON is a file format that you can open in any text editor, but you're better off working with it in an editor that knows something about JSON, because you can manipulate it in certain ways that are made easier. In this case, I'm using Oxygen for that purpose, and we'll come back and talk a bit more about some of the possible editing approaches for JSON in a bit. But here is the Oxygen XML editor, and right up at the top, what I've got is just one big long line of all the text in that file, which is pretty hard for a human to work with. Oxygen understands how JSON is structured, so I can have it format and indent, and it'll just do the right thing, putting individual data elements on separate lines and providing some indents so I can see what I'm doing. Is this at all legible at this point, Gabby?
No.
Okay, right. Stand by while I bump up the fonts. Is that any better? It helps a bit? Okay.
Yes.
All right. So basically, and I don't want to get too much into how GeoJSON is structured, but JSON is a general format, and what we're looking at here is something called Geo JSON, which is JSON used for geographic purposes. And its principal top-level structure is to define a collection of features. Features are geographic items of interest, and then to describe those features, each feature is then described by a series of properties. So here we see our basic name, the English name, had there been a Greek name, and so on, the PID or Pleiades ID. And in addition to these properties, also the geometry. So this is the purely spatial bit, in this case a point that has two coordinates, which are in latitude and longitude, signed decimal degrees. And so as you scroll your way down the page, you can see this same kind of basic structure repeated. This should look, though the specifics of the syntax are new, this should look familiar in that these are the same kinds of things one finds in the Pleiades record, and they are the same kinds of things we saw in the columns in the various displays in Antiquity Ala Carte. So in every case, we're working with the same data, but we're moving it from one kind of visual representation to another, or we're moving it from one kind of data structure to another. But we've got the same information lurking in here. So with that quick look at the contents of our JSON file, I want to go on and try to see if we can make a map with this in another tool. I should, before I close out though, I should point something out. You'll recall that in Antiquity Ala Carte, we have these coastlines in here, we have the blue water, we could have turned on or off various other things, and we have fonts that are being used for the labels. We have different kinds of dots that are, for some reason, being put in here. If we look critically at our JSON, we won't see any of that. We won't see any information about color. We won't see any information about dots or squares or diamonds or hollow points. We won't see any font specifications. So JSON in this particular case is being used to communicate with us only the geometry, so the Earth surface coordinates, and these basic properties of the features, not how we want them displayed. So there's a very strong distinction between basic data and presentation. And this particular JSON file we're looking at encodes nothing about presentation. It only encodes descriptive information about the places we're interested in or that we've selected. Right. So we'll get out of Oxygen and go back to the web. And we can go back to using Chrome. And we're going to go visit Carto.com, which is one of several competing tools online for making your own maps. This one complete with a very red homepage. You have to get an account. While the web is slow. Apparently we're waiting for some third party with some information, with some piece of JavaScript to actually execute. That is not happening. Let's see if I can stop it and try again. It looks like maybe having a little bit of a network problem here. So, yep. Looks like Carto is down. So I'm going to move on to another portion of my discussion. Gabby, are you still reading me?
Yes. Yes,
okay.
You broke up very briefly at the beginning of when you had those problems. The audio also went briefly, but it seems to be back and fine.
Interesting. Interesting that the Google Hangout is still working because the rest of my network connectivity looks to be down.
Cool. Well, it was still working, but I think we've temporarily lost Tom for a minute there. Let's give it a minute and hope he comes back. He said he was having network issues today, but it normally lasted only a few seconds at a time. So let's see what happens. Hi, Tom.
Yeah, hi. Looks like you finally did lose me there. Can you hear me now?
Yep, you're clear.
Okay. Yeah, it looks like we had a little bit of some kind of a network blip here. I apologize for that. We'll get back to our previously scheduled screen sharing right now. And I'm going to try Carto again on the assumption that that was not what knocked me off, but rather it was the local internet service provider not being as great as I would hope. Right. Okay, so I've logged into Cardo, and it's giving me its little friendly introduction that's basically telling me that, hey, we do maps, and I would like to do that. I want a new map. So I'm going to go to my so-called builder section. Oops,
Your microphone is very crackly at the moment, Tom. I don't know if it's moved from where it was before.
Huh. No, it's right where it was. I wonder if we're having some other problems that are involved. Is it getting any better, or is it remaining bad?
It's not terrible. But it's as it would. Yeah, it's just a bit fuzzy, but it's fine. Carry on.
Right. So sorry about that. The first step one wants is to get some information into Carto. And what I'm struggling with a bit here is that the interface has changed since I looked at it this morning about 20 minutes ago. Here we go. Right. So I now have the new map button, which is what I was looking for. We must have just seen also an upgrade to Carto. And if you click on new map, it takes you somewhat counterintuitively to the add dataset selection screen. And that's actually about getting your information into the map. What information do I want to use? I've been here before and have poked around a bit, so there are a few data sets already defined. But what I want to do is connect a new data set. Carto gives you various tools for connecting data sets from other sources. I have the slightest idea how to connect from Twitter works. But sort of Google Drive, Dropbox, Box, you can understand that some file that's already there would be useful. In our case, we're just going to go straight to a data file on our local system. We're going to click Browse. And we're going to go to the Downloads folder, which is where the export we had from Antiquity Ala Carte was waiting. So we now have cart export. It's figured out that it's JSON file, and we want to connect the data set. It'll give us some feedback about that process. As it tries to import it, it's making sure it understands what kind of information is in there, and it will now show me the map with that item on it. So here we have the exact same information that we were looking at in Pleiades about places called Apollonia, the exact same information we were looking at in Antiquity Ala Carte, but it's displayed in yet another mapping tool with some other default set of formatting options. Same information, but the look and feel of the thing is a bit different. Let's poke around the Carto interface a bit now that we've got our data in here and see what we've got. Perhaps the most obvious thing right at the beginning is this distinction at the top between map view and data view. I'm going to click on the data view and discover, there's a tabular display of information. We're on to another theme we'll see in lots of tools for doing mapping and geographic analysis, which is the alternation between a tabular listing of your information and a map view of your information. There's the visualized view, the map, and there is a table or other pop-up presentation of the individual bits of information about each place that you're mapping. Go back to the map view and ignore its suggested that there might be some other data sets of interest for now. and look at a few other things. Along the right-hand side are a series of perhaps intuitive iconic menus. Number one is Cart Export 1. This is the layer we are actually working with. So these other buttons are somehow related. SQL, this is a tool for allowing you to build queries against that data set that's in that layer, and thereby select some of the material, but not all of it. We won't dig into that in any detail today. Wizards are tools for mainly working on your map display. By default, we've been given a simple mechanism for displaying the features that are in this cart export layer. We can change them. I can switch from orange to blue dots. I can change the size of my dots. I can engage in various kinds of graphics manipulation that would affect how this particular layer interacts with other layers in the map. Since I don't have any other layers other than this basic background map, that's not really very useful at the moment, but it's there. And I can also choose what I would like to see used for labeling, and it will go ahead and do labels. So far, these are all features that are more or less available to us in Antiquity Ala Carte, a couple years newer in terms of web programming and so on, but the same basic stuff. We do have a number of other representation tools available to us that we can play with to see what happens when we reinterpret our data visually. So there's a lot of canned, ready-to-go visualization mechanisms in the map in Carto that you can apply at the layer level. One other to point out, categorization, you can choose a column in your data and categorize things based on it. So for example, we have different feature types in the data, different feature type strings anyway, and we can assign a different color to each one. In this case, we have things that Pleiades only knows as settlements. We have things that are known as settlements with ports, settlements that also include road stations. I think we've got one working up here. Yep. And somewhere there ought to be a settlement plus temple. Yeah, there's one. So the category tool is another nice one as you're beginning to explore how you might display your data in Carto or other tools. Info window lets you control what happens when you hover or pop up on the map. So in this case, I would like to see, when I click on them, I would like the base name and the feature type to pop up, and maybe the time period. So having done that, I get the base name, the settlement feature type. So here we're able to customize a pop-up on an item just however we want it, based on the data we already have. You can also have it do things just when you hover. So the basic functions of the mouse are scriptable. If you want to go beyond the built-in wizard colors and so on, this is a web page. It's being delivered to you in HTML and CSS and scalable vector graphics. So you can actually manipulate the cascading style sheet code that is being served along with it to create other features that you might want to have done that are not catered for by the Carto interface itself. This is an advanced task, but these kinds of functions are available to you. You can add a legend to your map. There are various ways to filter your data, and you can add additional features to the layer right here in Carto if you've forgotten something or you want to point out another location. So that's all the nifty stuff that's over on the right-hand side of the screen. We also have available to us various other options for adding titles and descriptions, and whether or not zoom controls are enabled, and so on. We can also choose from some base maps that already exist. If we like the watercolor look, we can go with the built-in watercolor background. We can go dark, which I think is not very helpful with this particular data set, or we can go subtle, or even subtler. So there are some built-in options for backgrounds. There are advanced capabilities to add your own from external sources, whether they be a web mapping service, from the NASA Worldview Base Map Collection, from Mapbox, which we'll tell you a bit more about in a minute, and a resource called Geo JSON. So there are extensible mechanisms for customizing a map if you're prepared to spend the time on it. Having got your map in Carto, you can export the image. You can adjust exactly what you want to see in the export. And then that's what you get. Your formats available are the PNG or JPEG format. And you can get that then to do something else with. You can also preview the map of how it would look live on a mobile device or on your desktop, which is what we were looking at by default. And then there are mechanisms for actually publishing your map digitally on the web. So you can download the image and go do something with it, or you can have the thing be live either by giving people a link or by embedding it in a couple of different ways in your website. So there's quite a lot of features for exploiting the map that are available to you once you get something going. So that's our relatively quick overview of Carto. We've looked at one possible workflow that moves from getting to know data in Pleiades to getting that data extracted by using the antiquity Ala Carte tool and getting it into Carto for the purpose of styling it and grooming it as a map. All along that process path, you can substitute other tools. You may have spatial data that's coming from somewhere other than Pleiades. It may be spatial data you've created, which is a bit beyond the scope of our discussion today, but you could still then, once you had it in JSON format, you could bring it into Carto and do with it just what we've done here. Similarly, we might go from Pleiades by way of antiquity Ala Carte to some other tool, not Carto. So I think that in terms of a basic set of approaches, the get to know the data, extract the data, package it, and then map it, that's a pretty generic workflow for the kinds of things you're going to want to be able to do. Before we leave Carto, are there any quick questions, anything I've not been clear about in a general way? Right. So let's.
Before
go ahead,
before
Gabby.
you start the next thing, could you try maybe unplugging and plugging back in your microphone, because it's still crackling quite a lot. I don't know what happened.
Can you hear me now, Gabby?
Yes, and the crackling's gone. It's perfect.
Right. So I don't know what happened. It looks like it looks like the Google Hangouts tool got in a fight with my computer settings, possibly during that network problem about what device to use. And so I went and reset everything in both of them, and it seems to have cleared it up. So my apologies. Right, so, okay, now that we've got over the second irrelevant technical hurdle of the day, let's go on to our next portion of the presentation. So we've already met GeoJSON or JSON in the form of the data that we looked at briefly with the Oxygen editor, the stuff that we got out of Antiquity Ala Carte and that we put into Carto. I want to talk about it and comma-separated values because these are the two key file formats for storing spatial data that you're likely to encounter or likely to want to encounter when you first get started doing this stuff. Although we'll then go on and talk a bit about the jungle that lurks behind them of other possible formats. But so JSON, this acronym stands for JavaScript Object Notation. So this is a format for describing information objects that came out of the JavaScript community. So this is a web programming language that's used in lots of websites for dynamic functions. It's also used for other things. And this was a data format that was designed specifically for sending information around on the web to be used by JavaScript code. And so that's its origin. The geo in the name here signals its specific use for geography. And what GeoJSON does is it says, right, there's this basic way defined by JSON for storing information to share around. And it's basically you can send named values and lists of values and structure them hierarchically. And that's all JSON says you can do. GeoJSON says, right, we're going to use that for the purpose of sharing information about spatial features. I've given you in the slide a couple of links. One is the formal definition of GeoJSON, which has come out as a request for comments from the Internet Engineering Task Force, and then a on some levels more accessible, what is JSON, how can you get started getting to know it, sort of blog post from Tom McWright. It's about a year old. One interesting fact about GeoJSON is that it actually has part of its origins with the Pleiades project. One of the principal authors of the GeoJSON spec is Sean Gillis, who now works for Mapbox.com. At that time, about 10 years ago, he was working for Pleiades, and his work on beginning to develop the GeoJSON idea and the GeoJSON spec, which he was doing collaboratively with others, was supported as part of our work on GeoJSON. So there is funding from the U.S. National Endowment for Humanities and other things that's gone into the creation of this spec for spatial data that I should emphasize is widely used globally and by no means limited to the humanities. In fact, it is the sort of primary format for web-based mapping at this time. The other format that I want to mention to you, and I think we've encountered this before, and we certainly will again before the end of this course, is comma-separated values. This is a venerable format that goes way back, and it's basically how do you represent a table in a text file. And what you do is for each cell, as you work your way rows and columns wise through the data, you put a comma between them. When you have text in there that might contain commas, you have to wrap it in something, and there's a convention for that. In 2005, the Internet Engineering Task Force approved a request for comments describing the basics of comma-separated values, but in fact, it's a format that was in wide use long before that, and this was, just trying to formalize what we've got. A couple things to say about both of these. Both JSON and CSV are simply text files. They're not binary, they're not proprietary, they're not weird. You can open them up in any text editor and take a look at what's in them, and it will make some kind of sense. The difference between them comes primarily in that they're using different conventions for structuring the information inside those text files. So how you distinguish one item from another, how you express relationships between items, and so on, is a different set of conventions. CSV is essentially mimicking a table, whereas JSON uses hierarchical structure and lists to try to produce a more sophisticated model of information objects, if you want to use it that way. But so the one issue, it being text, that you need to keep your eye on if you're working with it is character encoding. This is the same thing that happens to you with other kinds of text, and it's how the characters in a string of characters are represented and turned into the particular characters you actually want to see. JSON, and therefore GeoJSON specifically, is encoded using the UTF-8 encoding. So it was born in the Unicode age. They picked a particular Unicode presentation or Unicode serialization format, UTF-8, and that's what it uses. Comma-separated values is a much more agnostic format. It began life in days long before Unicode, and there are still some tools to this day that will always assume that the encoding is either ASCII, which was the dominant Roman character format before Unicode, or it will assume it's the native encoding of whatever operating system you're using. So you have to watch out with comma-separated values for what your tool assumes or lets you control about encoding and working with it. And there's a caveat here. Microsoft Excel, most versions of it assume that the encoding of CSV is ASCII. And so if you are working with UTF-8, Greek names, Hebrew names, Arabic names, anything that's not basic Roman characters, you may well find a pass through Microsoft Excel, which seems like a great way to display tabular data, clobbers your text. And so you've got to watch out for that. So that's one caveat I'll give you at this point. There are actually some large number of data formats out there used for spatial information or used for information you might want to pull into a map or into a geographic analysis. We're not going to try to work through them all here. I do want to alert you to the fact that there are a couple that you will hear about or see a lot. One of them is the so-called shapefile. This is a binary and proprietary format that was created by Esri, the company that makes ArcGIS. And it was designed to improve upon even earlier data formats that were mostly associated with particular sensors or other mechanisms of gathering data in the early days of GIS. The shapefile was an attempt to get to a generic format that you could put specifically vector information, so these are points, lines, and polygons, into it and have it associate with geography. Right out the bat, I need to tell you that there is one nefarious thing about the name shapefile. A shapefile is not a single file. It's actually a group of files that go together, and they contain the information, variously the information about the projection that's used, and about the coordinates of the features, and about the structure of the additional data associated with the features. So working with shapefiles requires that you either use a tool that's aware of that structure, or that you're careful to keep things logically grouped together and that you understand a bit about it. The Wikipedia article is actually a really great introduction to shapefiles. The reason I talk about it here is because they were and still are widely used. The format is well understood despite being proprietary, by a number of tools, including open source ones, and so you'll often encounter data in shapefile format. You should approach confidently, though with some caution. The other one, of course, to talk about that we see a lot of in the last 10 years is Keyhole Markup Language, or KML. This is the language of Google Earth. It is called Keyhole Markup Language for legacy reasons. It was developed by a company called Keyhole, which built the original Google Earth visual globe, and then were acquired by Google Earth, which is how it got its name that we know today. The KML file is actually an XML file. It's in the extensible markup language, so it is Unicode capable. This format has since been adopted and formalized by the Open Geospatial Consortium, which many people believe is part of Google's strategy for getting out of the digital globe business entirely by moving the format off to OGC. But that's just rumor right now. In any case, the important thing to know about KML, other than the fact that it's tied closely to Google Earth, is that it differs from GeoJSON, from CSV, and from Shape in an important way. KML is fundamentally a markup language for describing mapped features. So it does include formatting. It will include information about fonts. It will include information about the kind of pin or symbol that you want to use in Google Earth and what color that is. All of that stuff will be found in the file along with the coordinates and along with the descriptive structured data that you want to use. But it's tied closely to Google Earth. You will find, as you get more into spatial things, that there are plenty of software tools that can read KML, that can read CSV, that can read Shape and convert them to other formats. So these are not completely separate streams, but you do have to be ready to wade into a polyglot environment when dealing with file formats and collecting data from other sources. So how do you work with this stuff? Well, I wanted to point out a couple of tools just by way of example. The first one is GeoJSON. I'm not going to give you a demo of it for two reasons. One, we don't have time, and two, it's actually really easy to use. The same basic idea that you go to it, you get started, and you upload a GeoJSON file is with us. And you can play with it there. It gives you ability to edit the GeoJSON directly. It's a great way for learning how GeoJSON goes together. And it can be quite useful for putting together a map as an alternative to Carto. LibreOffice, I point out, because unlike Microsoft Excel, it gives you explicit control over the encoding of CSV files when you open them and you close them or save them. So if you do find that you want a tabular spreadsheety kind of tool for working with a large collection of data that you're going to either load from CSV or save to CSV, I would recommend LibreOffice because you can control the encoding and make sure you don't lose your text. And of course, the thing never to forget is your text editor of choice. You will need a text editor that understands UTF-8. Encoding. You will also need one that uses plain text by default, and ideally you'll get one that has some functions for dealing with structured data like CSV or like JSON. So this is my final slide, which tries to drop probably 3 or 4 courses and a year and a half of an undergraduate curriculum in digital cartography into one slide, which is to say it's going to do a terrible job. But we forge on. There are a lot of considerations that you need to take on when making a map. I've found over the years that a lot of historians, and I say this as a historian, tend to approach mapping as sort of a final component of getting a publication together. Work in historical GIS and spatial analysis for history is changing this, but you can still encounter plenty of people who will come to, I need a map because I need a map to go in my book or to go in my presentation or to go in my journal article, and I need it now. I've got all the work, all the research work done. I just need this map sort of as illustration. Often there is a research question or a pedagogical goal or even a rhetorical agenda that's lurking under that desire, but it's often not explicitly expressed. If you're going to do some mapping in any serious way, I'd suggest that you step back and think about, why do I need a map? What do I want it to convey? To what audience? And look at other example maps that will give you ideas about how best to do that. There are lots of choices in all these other bullets that you will want to make in an informed way if you understand and remember why it is you're making the map in the first place. If I want to communicate how close or far apart something is, I may choose different elements of design than I would if I was trying to illustrate density, for example. We've already encountered this notion of layers, thematic layers that are metaphorically stacked one atop the other to make a map. I wanted to take just a moment to explain why this metaphor is with us. It goes back to the 20th century process of cartographic production that predates digital map making. And it was one in which multiple layers of transparent material were piled up and then photographed in order to make maps. And the layering process was one that not only brought together different thematic components, but also could be used to mask items on layers below, to deal with, let's say, river drawing that overshoots the coastline, and then you lay the water on top of it, and it occludes the bit of river that you didn't want. So a lot of thematic process and cartographic process of getting a map that has lots of different things on it by dividing up the concerns thematically. You start with the landscape, then the rivers, then the coastline, then the roads. And so you build up this layer cake of thematic elements that are then shot photographically and printed to produce the final map. That whole structural metaphor and process was brought wholesale into the early geographic information systems because it was familiar to all the sorts of people who were using this material. And it was a way to group information in files. So we have one file that's the coastline, another shape file that is the rivers, another shape file that is the roads. And these could be worked on separately in terms of getting them ready to go, and then the process of compositing them into a map and applying style and formatting and so on could be done as they're stacked together. So most tools for making maps digitally today still incorporate this idea as a way of organizing the work and of structuring the visual presentation. So that's why you encounter layers as a concept. You'll find them in non-cartographic graphic tools as well. We don't have time to go into all the details of cartographic design, but there are a few key areas that I want to gloss before we turn around to question time. If you're thinking about making a map or group of maps, you need to consider the scale of the map, which has a direct relation to zoom level if you're talking about a digital map. So this is how many units on the map correspond to how many units on the Earth's surface. You have to think about what the extent of the map will be, how many pixels across, or how many inches across in your book, or so on, and how those two elements, scale and extent, interplay together in terms of how big your labels can be, how many points you can have, how close to each other, and so on. And distribution of features. This is a thing that can be a gotcha a lot of times for people who are coming to the map making process late in a publication effort. They'll have 73 places in central Italy and one in Afghanistan, and they think they're all going to go on a single map that fits in a standard Oxford hardback format. What you'll have if you do that is this map with one dot out in Afghanistan and a blob in Italy, and nowhere to put the labels. That's an exaggerated case, but I've seen it happen more than once, where you really have a combination of the limits of how you're going to display the map in terms of size and extent with the distribution and necessary scale for the features. So this is one reason why the new crop of digital mapping tools are great, because you can get in and actually play with your data and say, oh my gosh, I've got these outliers. How are we going to deal with this? Do we need two maps? Do we need one at a large scale, one at a smaller scale? Projections, accuracy, and precision, which we haven't talked about. The whole business of how we get from a roundish globe-like thing that is the Earth with a misshapen surface and so on to a two-dimensional representation in cartographic space. It's non-trivial and requires math. You have lots of choices available to you in terms of how that's done. This is not a new concern. This is what Ptolemy's geography is really all about. The coordinates in the back of that thing are really just fodder for making the maps he describes, and sets you the task of making in the rest of the work. What base layers we'll use. We played around with these in Carto a little bit. You need to think about how well they show off or hide or underplay or emphasize the other material you're laying on it. This concept that cartographers talk about of figure to ground. The figure is the thing you want to draw attention to. The ground is the background that needs to be there for spatial reference or context, but is not the primary concern. How well can you see that? How well is it understood to the audience that you're targeting? So on down the raft of choices around symbology, points, stars, triangles, colorful things, and so on. What you want to label with, how you want labels. Do labels include geography underneath them? How do you deal with places that are close together in the placement of labels? All of these are concerns. Legibility and accessibility is another area of concern. I see maps over and over and over and over again that use red and green to distinguish between two categories of material. Right there, you've just left everybody who is red-green colorblind out of understanding your map. So there are concerns around not only how legible something is, something that was a challenge to us here with some of the web pages I was showing you over screen share, but also issues of real accessibility in terms of public space and public humanities. Other concerns that the digital humanist will encounter, I'm going to skip over documentation here because I think it's just kind of more of the same in terms of caveats. You need to think about it. Two issues of copyright and licensing. Where did you get your data from? What were the rules governing reuse of that data? Are you required to document or attribute the source of that data? And if so, in what context and how? Are you going to disseminate the data you've created or massaged or changed to make your map? In other words, are you going to give your audience the ability to make their own version of your map by taking your data and loading it into something like Cardo and playing around with it? Are you going to digitally archive your map? And if so, are you going to archive it along with the data that was used to create it? Again, in the interest of reproducibility or interrogation of the findings you're presenting in the map. These are all concerns that I think are best at least acknowledged and thought about at the beginning of a project rather than at the very end. Because you can find yourself spending many long hours at the keyboard trying to solve these problems on the fly. And you'd rather not have them be surprises. So I think that is pretty much the arc of the presentation I wanted to make, and we're probably best served by opening the floor to questions. Yes, Gabby?
Yeah, great. Thanks very much, Tom. That was brilliant and thorough and useful, I think. If anyone else has any questions, I'd encourage you to unmute and join in rather than write in the chat, because we don't always notice that. Just checking if anybody's left any comments on YouTube. It doesn't look like it. Nope, don't see anything there. I was wondering, and this is sort of only half a question, so I'm not sure whether it will turn into a question in the process of my asking it. But I was wondering about the features of some of these mapping tools that you've talked about. Mm. You showed us Carto, and you can do some of the same things just with something as simple as Google Maps. Yep. And other kinds of tools. And I was wondering what features of Pleiades data, for example, or of other data that you get in gazetteers and atlases of various kinds, is not well expressed by this kind of a map. Or
Well, I think,
how
yeah.
good is the match between the data and those tools?
Well, the first and most obvious thing is we have lots of information in Pleiades that's not mappable. In the very basic sense, we don't have coordinates for it. We know the name of a place from an ancient source, but we don't know where it was. We might know it's somewhere in southern Italy, or we might know it's between point A and point B, but there either won't be any clear idea where it is, or there won't be consensus among the many and varied suggestions, which will mostly be based on, oh, there's a medieval village here or there that could be it, for example. So that's the first class. I think that, a map is just, if you can't map it, a map is not at your service. You can do some things. You can approximate if you kind of have the general idea at a given scale where something is. You can do what the Barrington did, which is use your symbology to draw a distinction between precise the locations that you consider to be accurate as opposed to those that you consider to be approximate. And the Barrington used a distinction between solid filled symbols and hollow or circular or otherwise hollow symbols to indicate that. So if you look at a Barrington Atlas map and you see some dots that are hollow, that's saying it's roughly here, as opposed to the solid dot, which says at this scale, I assert this is the accurate location. And so those hollow ones will generally be on the basis of either some ancient description that puts the thing between two other places, and this seems like a good spot, or it will be there's a lot of spolia in the area that is consistent with this this known or expected ancient place, and so we'll plop it here because most of the spolia is here. So that's the most obvious one. I'd have thought the other thing that's tricky, and we glossed over this, but Pleiades is not comprehensive for various kinds of feature designations. So it's moving that direction, but you will get settlements that also have temple associated with them. This will not necessarily be, you shouldn't count on every single temple in the ancient world or in every single settlement having been properly described in Pleiades. So if you go and naively do a category map and say, wow, there's only one Apollonia that had a temple, you've just engaged in creating a lie with a map. And that's about getting to understand the data you're looking at. And this is what most people who are serious about mapping from Pleiades find, is that it's good information to start with. You've got the good basic information in there, at whatever level of detail it's got, but then whatever your research question is, whatever your pedagogical goal is, whatever your rhetorical intent is with your map, you probably have to add to the data on the basis of your own scholarly investigations, your own scholarly understanding, the completeness or the additional indicia that you want to call attention. So does this place have a particular kind of architecture extant? Is this place associated with a particular office that we find in the ancient sources? So does this particular settlement appear as a site of Roman governor holding court? These kinds of things you're not necessarily going to find in your data source. You're going to have to do the research to add them.
Right. I'm thinking also things that are in the data that it's not obvious how to map them. There's no single convention for how to map them. Things like time, movement, multiple names. These sort of features. I mean, we can imagine having multiple maps with with changing territories and so forth, but that's that's not always the nicest way to represent things.
Yep. No, I think you're exactly right. It's what names will you use? Will you use the ones that you think are best known to your audience, or will you use the ones that you think correspond to the period or periods you're describing, or will you use all the Greek ones? Will you only use modern? These are all concerns that you're going to have to take on. And what are you going to do with time and change over time? Yeah.
The Barrington Atlas had maps. I mean, every map in the Barrington Atlas included places that never coexisted, right?
Correct. Yeah. The Barrington Atlas was a extended exposure snapshot. Each map was over a period of between 1,000 to 1,500 years, depending on where you were. And if you had a place that only corresponded to one of the 5 periods the Barrington recognized, and they were very, grossly defined for practicality's sake, they would use a color highlight under the label. But if you had a site that persisted across at least 2 of those periods, and many of them did, then you got no such underline, and you had to refer to ancillary material to deal with that. On the web and in digital maps, you can provide, the time periods and pop-ups, but you're still requiring the user to ask the question. There's been a lot of work done over the years with people trying to use animation to do time. So essentially, you use time to display time. You just rescale it. But this has varying degrees of satisfaction. You could imagine a oblique view of a map in 3-dimensional Cartesian space where the z-axis is not altitude, but is rather time. And so your symbol is a column stretched across the time period of interest. I've never seen such a thing that wasn't an artistic, wasn't a cartographic art production. I have not seen a tool that does that per se, although I think there are other kinds of displays for business and marketing purposes where you can build a column on top of a location on the basis of some data items. So there are probably tools you could adapt to that kind of a display.
I guess the advantage of a digital presentation of a map, rather than creating a map in order to put it on paper, is in addition to or instead of animation, you can use interactivity.
Yes.
So the user can interact with it and say, now I want to see the following time periods or the following span of time and or the following other criteria.
And you will see those kind of controls in a lot of websites. We don't have them in Pleiades at this point, but you certainly will see them other places. Yep.
Yeah, and you can choose to make distinctions between different kinds of settlements if the particular viewer is interested in them, but can ignore them otherwise. Yeah. Yeah. Cool. Well, if no one else has any other comments to add or questions to ask, we're almost out of time. I want to make a quick announcement about next week. Next week, the session, which will be run by Leafy Saxon and Alegria Perez, will be on GIS, on Geographical Information Science, so the third of our geography sessions. And the important thing to note about next week's session, in addition to the fact that you will need the QGIS or Quantum GIS open source package installed if you're going to follow along the exercises that they show us. So please try and do that in advance of the session. But the important thing to note is that next week's session, it does not yet say this on the web, I'll change it in just a second, will be half an hour earlier than usual at our normal time. So it will run in, if you're following it in real time, it will run from 3:30 p.m. until 4:45 p.m. UK time. This is for a variety of reasons. So that's something to note. I'll make sure that's noted when the emails go out next week, and I'll change it on the website immediately. So that's the main thing I wanted to say about next week. Obviously, next week we'll be building on this week, so if you get a chance to play with the tools that Tom's been showing you this week and work through some of the workflows that we've been talking about this week, that'll set you into good stead for the assumed starting point for next week's session as well. So, okay, thank you very much, and thanks especially to Tom, and I'll look forward to seeing you all next week. Cheers.
Bye.